have the Duologue1, which is the Duologue first session. We have generative AI in manufacturing. And to kind of take over this session, we've got another, I would say, holistic set of leaders and very fast emerging leaders in the analytics AI space. Let me also tell you, I have a privilege of knowing all of these speakers, and it's really awesome when you speak to them, because the kind of I would say experience you gain is phenomenal. You can't even do, I mean, it's akin to kind of doing 1,000 projects in kind of, let's say, 50 minutes when you talk to these leaders. We've got Biswajit Pal. He's a director, data engineering and insights at Tata CLiQ. And then we've got Amitabha Tripathi. He's a senior vice president, analytics at Aditya Birla Group. Both will talk about generative AI in manufacturing.
Now, there are few stages in manufacturing. It starts off with designing, it goes into prototyping, and then into production. And then finally, once the goods are ready, how can that be shipped from manufacturing unit to warehouse, showroom, retail stores, and etc. So what we will do, we will try to see that, how generative AI can be used in all these different stages. Right? So let me start off quickly with the design stage. Now, in design stage, now what does it involve, right? So essentially, when you're talking about the finished products, right? So essentially, the designer come up with a lot of designs, right? Now, where the generative AI can come in is basically that if you give them the correct constraints and the correct parameters, the generative AI can actually churn out a lot of designs based on the huge amount of data which they mine in the background. Now, so it has two major advantages. Number one being that the turnaround times is much quicker. And the second is basically that maybe, some of the designs which the manual human designers cannot think of, they might come up with, right? So for example, and the third advantage on a, lighter note is basically people like me who have no clue about the designing can also become a designer using a generative AI. Right? So now once the designs are done, it is easier for the engineering team to quickly generate the prototype, right? So it saves a lot of amount of human effort as well as time. Let's quickly come to the next part, which is about the actual production. So as I mentioned, that the production involves a lot of machineries, right? So now what generative AI do is that it mines a lot of data and study the pattern to come up with some of the anomalies which may arise, right, in terms of the pattern, which says that, okay, this particular machine may be not functioning well and it needs some amount of maintenance. So what it essentially doing is basically it's proactively raising alert to the manufacturing, saying that, hey, you know what, this particular machine needs some correction. So this saves quite a lot of time, and also it reduces the downtime significantly. The another aspect of the production is also about how to optimize the entire resource optimization or utilization, right? So through generative AI, if you can give the correct parameters, like how to tune the machines, how to synchronize the steps, what kind of cost optimization we are talking about, what kind of resource utilization we are talking about, we can actually seamlessly optimize this operational process. And that's a huge cost saving and also in terms of time saving. And another interesting aspect in production is about your supply chain optimization, right? So generative AI helps in like demand forecasting, inventory planning, and also how to seamlessly do the logistic, right? In that way, it helps to optimize the supply chain quite a lot. So these are some of the use cases where generative AI can come into the picture in terms of the various phases of the manufacturing, which are about designing, prototyping, production, and also how can we ship the goods out from the factory to the warehouses. So Amitabha, a quick question. So you have a rich experience on the manufacturing side of it and how to use AI. So how you are saying that this particular field is evolving, and if you can explain via a use case which you might be working on.
Sure. Vishwajit, great to be here and talking to you today. I'll start with an interesting anecdote that I came across. I read an article a couple of days back in newspaper. This was a survey by BCG on Gen AI impact. Interesting observation there. Just summarizing it, I'm just looking at the newspaper clip. Most optimistic about Gen AI impact, the top 3 countries. Imagine Brazil number 1, India number 2, Middle East number 3. Most optimistic, most bullish. Least optimistic, US, first one. Second one, the Netherlands. Third is Japan. Most concerned, the Netherlands first, France second, and Japan third. So it's very interesting time today to sit and discuss this. How do we do more with it? We are really bullish about it being in India. Now, you spoke about the context in manufacturing, Biswajit, and I'll talk about a couple of examples. Manufacturing, the core production, if I think about it, is huge. It has interaction from, I would say, raw material, fuel to machine, the set we call human processes. Customer is a big element of it. Customer expectation, what's the quality expectation? These are all different gamut that we try to interact with. And all the decisions in terms of machines, what maintenance is needed, what's the kind of feed, what's the firing of coal or a pet coke that you do, what kind of predictive maintenance happens, what's the quality parameters, the lab tests, they all depend on these interactions. Now, they're all managed by human operators. Naturally, the knowledge and the intuition comes in because human operators would develop intuition over time. But the point is we have over 300 plants and we operate in 12 different industries. All plants are different on their own because they deal with different quality of raw materials, the loads and the machines are maintained differently. So there are a lot of heterogeneous data in that process. A simple model won't do it. And then in the process, we have data, and I'll talk about this, maybe historical data that we have, parts replacement, maintenance data, work orders, think about manuals, troubleshooting documents, all of these. Now, and they're all in different formats, lying different places. How do we learn from these documents and then make sense of the data that is present in this? So one of the cases that is, again, it's early days, Biswajit, that's probably fairly new. We're experimenting in the areas. I would talk about a couple of areas that we're experimenting on. One is asset reliability. So say a bear temperature, the gearbox or the bearing temperature is high by 10 degrees. What should the operator do? If the operator has to reduce the fuel feeding or tweaking another equipment, there are some 100 or 500 such equipments associated with that bearing. What should the operator do? That's the concern. Now, typically they have top 3 or top 4 action that I probably maintain this bearing. That's the first one goes in my mind, right? That's what they do normally, typically. Or I would reduce the load. But is that the optimal recommendation? What would a 30 years experience operator, supervisor, executive would do in that situation? Okay. So what we are doing there, we're experimenting still, that we have a lot of these manuals that we have been able to digitize. Some were actually physical, and we were digitizing this. It's a huge set of documents, and we were now feeding that into the LLMs to get the recommendations in an interactive format. And the root cause, the reasoning comes in that why are we saying that you fix the vibration of this another one? I'm not saying the exact name of the equipment, but we are changing that in order to control the temperature here. Or a pot temperature is reduced by 5 degrees. If I have to put a fuel right now, how do I control that overall elevation? So that's the kind of constraint there. And I'll talk more about it also a bit later in terms of the challenges, Biswajit. I'll come back to that and how we are addressing some of these nuances while implementing such things.
Right. I think Amitabha, you are bang on, and one of the use case which I can think of, which has a good overlap between the manufacturing and the little bit retail industry, is basically about the choosing the right supplier, right? Because when basically it's a handover or a handshake between the two, right? That once you manufacturing unit produce the goods, whom should be supplied to, right? And we need to have the right supplier in place. And that is where I feel that, a generative AI has a great use case, because what typically the way it happens is, in order to choose supplier, we evaluate a lot of factors. Like, for example, what are the cost implications? What are the historical performance of this particular supplier, right? What is the reliability of this supplier? And then what kind of, what is the proposition, or what kind of value proposition the supplier brings into the table, right? So all this information can be trained using an LLM, because obviously there is a large amount of information available, and which will help to create sort of a supplier scorecard or a supplier portfolio along with the risk assessment of the supplier, right? So just imagine that once we have the supplier portfolio and also the risk assessment, it will be such an easy job to choose from that who should be the right supplier for this particular work, right? So I think that is a beautiful use case, where essentially, I think a lot of retailers are also trying. And as you mentioned, that it's more about the POC at this moment, and I hope that at some point of time we will start scaling as well. But you also mentioned about the the things we need to keep in mind, right? So can you just elaborate a bit on that? That what are the things while performing Gen AI in manufacturing?
Yeah, absolutely. So if I look at it, it started. It's not new. I mean, this whole generative AI concept in 2014, self-attention model, or GAN models in 16 or 17, things like transformer came up. But it took about 5-6 years now to get all of these things together to do really generative AI, where you can generate human-like languages. Of course, the obvious challenge is the scale part of it. That retraining these models take a lot of GPU, and where do we train them? They're expensive, and if we do not train them, we might lose the context, and then it's probably to hallucinate. And we have seen things like this, that my energy consumption is high, the recommendation could be reduce the load, don't produce so much. Now, of course, that's not useful. So to make it useful, you have to put a context there. So we have come up with a framework there. So we're using the LangChain framework today, where we feed in all our existing context from different manuals and troubleshooting documents, etc., and we extract the most relevant content where this theme is talked about, and then we use that in the context of large language models to generate what's useful for me, so that this hallucination is reduced to some extent. That's the kind of framework we use. The second thing that we have to keep in mind is that the impact of an error, hallucination, could be different in different industry, or different problem for that matter. So imagine there is a membrane, when we have a lot of these electrolyzer or energy systems in different manufacturing processes, there is a pinhole. Now, if my system says that there is no issue, continue, next best action, right? It says that no issues. But if there was an issue already, it could be a simple error from a language perspective. One word is different, but the impact is it can cause a huge safety issue, or a complete breakdown of the system. So we have to assess now that for each problem, what's the impact of such error? The third element is, can we create a test environment? That's what we are already doing today, to enable multiple users test the outcome of this, and then dictate that how do I enrich my prompt using the LangChain framework to provide more and more context. And I can actually play with that. It's through iterative process, that with this kind of a context, I'm getting more accurate results. And then can I use these results or the output of the recommendations in certain use cases, like, for example, maintenance is useful. For a very severe critical error, I probably should not automate this. So we typically use this kind of three-pronged framework to address potential challenges. And we're also looking at an architecture, which is a kind of mixed architecture, like a cloud and an on-prem, and some open source, like a Falcon kind of models as well, for the open source LLMs to really train our models. So looking at that. Thank you, Biswajit. It was great talking to you. And thank you, Samir and Bhaskar, for the opportunity to share these thoughts.
Thank you, Amitabha. It was a great conversation. Over to you, Samir and Bhaskar.
Thank you, gentlemen. Absolutely riveting session, almost a kind of a 10-12 minutes masterclass. Bhaskar, two questions out here also to demystify some definitions for our audience. What is diffusion and what is LangChain framework? Can you please explain quickly to our audience?
Sure. I'll give it a shot, and I think I was seeing those comments come in as well in the chat box. As you think about the different frameworks that are there and the kind of data that you're using, the context of the data is important. For example, diffusion models, which essentially work well with image and video data, and which is where the whole stabilization point that I believe Vijay was talking about in the chat comes into play. So image and video data is custom made for diffusion models to actually work well. On the other hand, as you think about maybe text data, that is where transformers are seen to perform much better. GANs, on the other hand, are a classic way in which you actually do data augmentation. So the key part here is not the technique, but understanding where that technique works best, contextualizing that to the process, and then leveraging it to drive value.